Now, let's talk about throwing in some variables with our roots. Of course, got to put some variables in there, right? What about the square root of x to the 6th? Well, in this case, let's think about it. Square root means, like square root of 25 is 5, because 5 squared gives me 25. So what I'm looking for here is what squared gives me x to the 6th, right? That's what this answer will be. Whatever I square to get me x to the 6th will be the answer I put there. What would I square to get x to the 6th? Well, remembering our rules for exponents, x to the, what needs to go here? 4? Not 4. What needs to go here? 3. Yeah, because there I'm multiplying, right, to get x to the 6th. Power to power you multiply. So it needs to be x to the 3rd. The square root of x to the 6th is x to the 3rd. Maybe not what you thought, all right? Square root of x, well, let's just do x to the 10th, and then we'll observe the pattern here. What would I square to get x to the 10th? X to the 5th, okay? So we do the square root of x to the 10th, we get x to the 5th. We do the square root of x to the 6th, we get x to the 3rd. What do we do into the power? We're halving it, yeah. To square root a variable to a power, you divide it in half. That's what happens. I mean, you can go through this process every time if you want, but the pattern is if you square root a variable to a power, the square root of a variable to a power is the variable raised to the power divided by 2. Half the power is halved, in other words. Okay? So putting that into play here, what about the square root of, well, I just did that one, didn't I? What about the square root of y to the 30th? What's that going to be? Y to the 15th. Yeah, you just take the power and divide it by 2. And that's your new power. Okay? So it's pretty nice to do square roots of even powers. Now, there is one little catch. For this to work, because of the the negative, you can't do the square root of a negative thing for real numbers. For these, for most of them anyway, the variables will only be positive values. The variables have only, just kind of a little technicality there. For the most part, the variables for these only have positive values. But just a little side note there. We could get more technical about it, but for now, we'll just make that little note. Okay. All right. Okay. Now, if you get thinking about it, what are we going to do if it's an odd one? Well, we'll come to that. What if it's an odd power? We'll come to that here in a second, and we'll talk about that. Because if it's an even power, it's real easy. You just divide it by 2. But what we do with it when it's an odd power, we'll talk about that in just a moment after we do a couple other things. Okay? But that's variable to an even power, just divide it by 2 to square root it. Okay? All right. Now, what I wanted to talk about next, I call it the split apart rule. there's a couple of parts to it. Some square roots you can split apart. If you have times two things inside your square root multiplied together, you can split those apart. In other words, make it the square root of a times the square root of b. That's helpful. For example, if I have the square root of 25x to the fourth, this rule will be helpful there, right? Because that's saying, since these are times multiplied together, I can split those apart and make it the square root of 25 times the square root of x to the fourth, because what does the square root of 25 become? It's 5. Square root of x to the fourth is x squared. Yeah, so that one way to think of that, simplifying that expression there. Okay, now that's part one. Part two of the split apart rule says you can do the same thing, or what? My split apart rule anyway. Part two of it says I can split it up also if it's divided. A divided by B, something divided by something else. I can split those apart and do the square root of the top divided by the square root of the bottom. And so, for example, the square root of 36b to the 8th power becomes, well, I can split that apart. Square root of 36 over the square root of b to the 8th. Square root of 36 is 6. Square root of b to the 8th, b to the 4th. Okay. So those are two helpful rules. Now, I'll probably say more about this one next time, but let me go ahead and mention there's another side to this split apart rule. There are some things you can't split apart. The can't split apart rule. You can't split apart this. If it's the square root of a plus b, not going to be the square root of a plus the square root of b. Let me give you a for instance. The square root of 9 plus 16. If that was true, that the square root of a plus b equals the square root of a plus the square root of b, this would be the square root of 9 plus the square root of 16, which is 3 plus 4, 7. But what do I actually get? What is this square root of 9 plus 16? It's the square root of 25, which is 5. You see? It doesn't match up. It does when you do multiply or divide. It matches up. But it doesn't match up when you add. Have square roots and add in the middle. And same thing for minus. You can't split that apart. Cannot split apart square roots of sums, addings, or differences. Only multiply and divide. Products and quotients. Okay? So there's another side to it. You can't just split up any square root. It has to be a multiply or divide inside. If it's add or subtract, you can't. Okay? All right, one other quick one here. I mean, you can certainly extend this. Say the square root of 9 x to the 16th and then y. Make a couple of points about this one. Can I split that one apart? Yes. Why? It's multiply. Yeah, it's multiply, multiply. Everything's multiply. It's 3 things in the product, but that's okay. It's still, you can extend that split apart rule. You can split this apart. Square root of 9, square root of x to the 16th, square root of y. Now let me make a couple of points about what we get here. Square root of 9, well, that's 3. Square root of x to the 16th. X to the 8th. Why is it 8? Dividing it by 2. Yeah. For variables to powers, you divide the power by 2. Now it's tempting there to go with x to the 4th, but the square root of x to the power, you divide the power by 2. So it's x to the 8th. Now, what about this one? Well, there's just nothing I can simplify there, right? It's just the square root of y. Can I simplify the square root of y? No, because I can't really divide the power by 2 there. I guess I could write it as y to the 1/2, but usually, typically, they'll stick with this notation here. So, yeah, if you just have a y or an x, that's technically the first power, you just can't simplify when you do a square root of it. So it just stays the square root of y. You with me there? That's a simplified version of that. Okay? All right.